Alright, so now that we have finished Chapter 5, we can move on to some basic statistics, which will be from Chapters 1 through 3 if you decided to purchase the textbook. One kind of note, as it says there at the top of the notes, I don't necessarily go in the order of the textbook. Again, I know a lot of you didn't buy it anyway, but if you were looking in the book, and not in that exact order. But I've grouped things together in a slightly different way to hopefully make things connect a little bit better for us. So we're going to start by just understanding what a statistical question is. The reason why this is important to us is because really the main goal of statistics is to use data to answer questions. And so we've got to start with what we refer to as a statistical question. So what is a statistical question? Well, it is a question that can be answered by collecting data and where variability is expected in that data. This might bring up the question of a key word inside this statement, and that's the word variability. So what do we mean by the term variability? Well, that is a term we're going to be using a lot in this set of notes, so the more we can kind of go through and explain it, the better. Really, the idea of variability is really that I'm just looking for some differences. So that is when I ask people a question, and I'm getting these answers, I don't expect all the answers to be the same. And so I expect there to be some different responses in this data. So we're going to start by talking through some examples of statistical questions, as well as ones that are not statistical. So a first example of a statistical question may be to figure out what percent of NKU students are currently enrolled in a statistics class. So why would this be a statistical question? Well, in order to answer that question, I'm going to have to figure out if an NKU student is enrolled in a statistics class. Some are going to be yes, and some are going to be no. Even though there's only the two possible answers, those are still different answers. Not everyone is going to be the same. Or I don't expect everyone to be the same. Another example of a statistical question is to figure out about how many credits do students have at the time they graduate. So if I were to find out this number, I'm expecting that not all students are going to have the same number of credits at graduation time. So I expect there to be this variability. And I can answer this question by collecting some data. A third example. Maybe I would like to figure out how much snow will we get next year. Now this one might seem a tad bit harder because we don't really understand maybe why there's variability in this answer. The important part of this is that we're looking at next year. So I don't already know the answer to this question. In a sense, I'm going to try to predict the answer to that question. So how can I use data to help me answer that question? Well, I could look at how much snow we've gotten in the last few years, take into account maybe the different temperatures that we've had over the winter time. I could look at the Farmer's Almanac and collect some data there. So there's lots of things I could collect information about to help me predict that number. Depending upon what data I get, I am going to probably get some different answers of how much snow I think we're going to get next year. So to look at the opposite, let's talk about some questions that are really not statistical. And we're actually going to look at these related to the ones that are statistical. So when I'm looking at the percent of NKU students who are enrolled in a statistics course, a way I could phrase that is not statistical is just asking, are you enrolled in a statistics class this semester? So the reason why this one would not be statistical is because there's not going to be variability expected in that question. With the way it's phrased, I'm only looking at one person, right? Are you? So I don't expect different answers every time I ask you that question. The answer should be the same right now. Like that shouldn't change. There should not be that variability. So the way looking at the number of credits students have would not be statistical. It's for me to ask, how many credits did you have when you graduated? Because again, if I'm only asking that one person, shouldn't change. All right, finally, to understand how the snow one can be phrased differently, that it would actually not be statistical. Instead, I could figure out, well, how much snow did we get last year? The reason why that one will not be statistical is because there is an answer to that. And I can get that probably relatively easily. I'm not going to be collecting data that's going to have any variability to it. There is going to be one answer attached to that one. So the idea here again is to understand how I need to phrase a question for it to be statistical, which is also different though than the question I might actually ask someone. Right, in order to figure out what percent of NKU students are enrolled in a statistics class this semester, I'm going to have to ask some individuals if they are enrolled in a statistics class this semester. So although I might be asking this question of students, that's not the statistical question. This is what I really want to know. This is what I want to actually answer. That's the goal. So again, the goal of statistics is to use data to answer questions. So in the next class, we're going to get to collect some data to see if you can figure out the question.